So in this video, I'm going to recap some information about time series analysis and forecasting. So the first thing to talk about is what kind of data is actually suitable for this type of analysis. So there's a couple of different criteria. The first is that since it's a time series analysis, we need to make sure that we're collecting the data over time, and it also needs to be on a regular basis. So it could be every year, it could be every month, it could be every day. All of those would be examples of collecting data over time on a regular basis. The next thing is that we need to make sure when we are using our data that we've organized it in chronological order, so from the beginning of time up until the end of time that we've got for the information. The last thing is that we can't have any gaps in our data. So if you've got collected data over different years and you're missing like 2011, that's going to be a problem for this type of analysis that we're going to look at. So once we've met those criteria, we're going to be able to analyze our data. So what we're going to look at is four kind of components that go into our time series. So the first one is the long-term trend, which we're going to give the letter T. So as the name suggests, this is like the long-term projection. So whether it's going up or whether it's going down, kind of over that long term. The next thing that we're looking at is the cyclical effect. So this is kind of similar to a seasonal effect, except that when it's cyclical, usually it's over a longer term than a season, and it's also not going to be tied to a calendar event. So it's not like every January we see a spike. It's just kind of less predictable than that. Okay, whereas when we look at seasonal effects, this is something that is absolutely tied to the calendar. So like I said, maybe every January you see a spike. It could be days of the week, so you see more sales on a Sunday, for example. That would be a seasonal effect. The last one we have is kind of random fluctuations. This is like our error term. So there's always going to be some level of unpredictability in our data, and that's what this last one here is accounting for. So there's two types of models that we can use to make these predictions. So the first one is called the Multiplicative Model, and that's because, as the name suggests, all of the different terms that we are considering are getting multiplied together. And you'll note that these relate back to the four different components that we can have potentially in our model. Okay. The other version is the Additive Model, and that's where we add them together instead. And all of these are kind of inputs to our model, and what we get out here is kind of the prediction of whatever the data is that we're looking at. So if it's sales, then we will be predicting sales at some time period with the little t. So which one we use kind of depends on the application that you're looking at, but most of the time the multiplicative model is going to be the one that we use. This is because like the values that we get out for each of these different components get multiplied together, making them kind of proportional to each other. Whereas in this additive model, kind of they're all treated independently. So the size of TT doesn't really impact on the size of ST, whereas here they will because they get multiplied by each other. So yeah, this tends to be the one that represents more kind of realistic situations most of the time. So that's the one that we're going to focus on in the examples coming up. So the next thing to kind of talk about is where we get each of these components from. So if we scroll down, the first one is the trend component, which was the capital T. So this one comes from applying a regression model onto your data. So from that, you should be able to get out an equation which is y equals, and what fills in here is the coefficients in the independent variable equation. Just to note that the y with a little hat on the top is the notation that we're using for this theoretical prediction or the trend data. So the next one is the cyclical component. So this one is expressed as a percentage of the trend. So you can go and calculate it if you know y, which is kind of the actual data points that you would have from what you're analyzing. And this little y hat here, this is like the prediction at the corresponding point. So all you're doing is comparing the actual and the predicted and multiplying by 100 to turn it into a percentage. So this here gives you, that cyclical component. So this one for seasonal, it's going to be expressed as an adjusted seasonal index. So it's kind of 2 steps to be able to work this one out. The first step here is to get, this is the seasonal index for a specific season. So if you're looking at it in quarters, maybe it would be for the first quarter you get the seasonal index. And how you get that is you take the average of y on y hat for that specific season that you're interested in. So say quarter 1. Again, y here is the actual value that you have recorded in your data, and y hat is the predicted, which comes from, again, doing that trend part first. So once you have the seasonal index calculated, you can adjust it, which is this second step. So the adjusted seasonal index for a specific season, for example, again, quarter 1, is equal to that seasonal index that you had for the quarter, multiplied by the number of seasons. So if you're looking at quarters, this would be equal to 4, divided by the sum of the seasonal indexes for all the seasons, okay? So we will do this one in an example, so hopefully you get a better idea of this in a more applied context. But that's pretty much it in terms of this video, covering off on all the concepts which go into our analysis and forecasting. So I hope you get a bit more out of the example videos in a moment. So see you there.